Okay, let's look at this problem here. Let's indicate the order of a reaction consistent with each observation. So this solution doesn't really tell us anything here, but I'll read that for us as well. So this is number 3, right? Number 3 is asking indicate the order of reaction consistent with each observation. This is A here, the half-life. So let me write this: the half-life of the reaction. I'm going to use Rxn for reaction. The reaction gets shorter as the initial concentration is increased. B is stating a plot of natural log of the concentration of the reactant versus time yields a straight line. Line. C here is the half of the reaction, the half-life, the half-life of the reaction Rxn gets longer as the initial concentration is increased. So that's going to indicate the order of reaction consistent with each observation. So let's look at these observations first. So the first guy here says that the half-life of the reaction gets shorter as the initial concentration is increased. So if I'm increasing the concentration of the initial concentration here, the half-life is getting shorter, right? So you can think of this as remember our rate of reaction, right? So you can think of the rate of reaction here. It would be R would equal, and I would have the products, right? So R would equal, let's say here, X times some Y here. And we want to know, or actually I have a constant here. This is K times X times some Y here. And this here's the rate of reaction. And this is the equation for the rate of reaction, right? So it's asking us if we increase the initial concentration here, the half-life is going to get shorter. Or you can say the rate here, it's gonna get smaller, right? So if that's the case here, it's definitely a non-linear. It's a non-linear order, so it can't be first order. But in this case, it would be the second order, right? Because again, if it's half-life, for example, if it actually gets halved, if it gets shorter, if I'm increasing X here, my rate here is going to get shorter here. So this first guy here is a second order, right? So this here would be a second order reaction. B here is asking us a plot of natural logarithm of the concentration of the product versus time yields a straight line. If it yields a straight line here, it means it's linear, right? So therefore, this would be rate would equal X here, and then this would be the first order here. So this is first order, and we can actually do a graph here, right? So we can say, we can plot here, just a small plot here. It says a plot of the natural logarithm of the concentration. Oh, sorry, not these lines here. I want so it says the plot of natural logarithm of concentration versus time, right? So this here would be, you can say this is ln X here. So this guy's ln, ln X, and this here is T. And as you can see, it's going to be a straight line. Like it can be a straight line going, I should probably use my line tool here. It's going to be straight down here, right? So this here would be a first order type of reaction here. Finally, C is stating here the half-life of the reaction gets longer, so it doesn't get shorter, it gets longer here as the initial concentration is increased. So if this was second order, this is first order, this one would be 0th order, right? So 0th order, because it doesn't matter, it doesn't matter what my initial concentration is, independent of the initial concentration. So this is a 0 order reaction. This would be R simply equals K. is x to the 0 here. So this here is simply just 1. So r here equals the constant simply. So this here is my solution for this problem, and this analysis here is correct as well. So solution is correct. Analysis.